Okay, so we're going to look at how to solve the problem with the family of ducks. So let's start by drawing a diagram. Drawing a diagram is always a good first step. So we've got a river here. It's 21 meters wide. Let's draw a little compass up here so that we don't get lost. That's north, that's east. And we've got a father duck who is standing on the south bank. So here's our father duck here. He's stationary on the bank. And then we've got a mother duck who's in the river. The river water is flowing eastwards at 1 meters per second. So here's the mother. She just flows along with the river water. So she is moving relative to the bank at 1 meters per second, but she's not moving relative to the water. And then we've got a group of babies who are swimming across the river at a speed of 0.35 meters per second as well, and they're going northwards with respect to the water. Okay, so part A says, what is the velocity of the mother duck relative to the father? Okay, well, if we do everything relative to the bank, the father's not moving relative to the bank. Relative to the bank, the mother's moving along with the river water at 1 meters per second. So we're asking for the velocity of the mother relative to the father, and so that's equal to the velocity of the mother minus the velocity of the father, and so that is equal to 1 meter per second eastward minus 0 because the father's not moving, and so this gives us 1 meter per second eastwards. Okay, now in the next part it says, what is the velocities of the babies relative to the father? Okay, so we've got the velocity, we're given the velocity of the babies relative to the water. So the velocity of the babies relative to water is equal to 0.35 meters per second north. And that's equal to the velocities of the babies minus the velocities of the water. So now we can get the velocities of the babies. This is equal to 0.35 north plus the velocity of the water, and the water is going 1 meters per second east. So we can draw a diagram to show this. We've got the water is going 1 meters per second east, and here's the movement of the baby, 0.5 meters per second north. So this here is the velocities of the babies relative to the bank. So to work this out, we need to use Pythagoras. So that's the square root of 1 squared plus 0.35 squared. And solving that one on the calculator, we end up with 1.06 meters per second. And then because it's a velocity, we should also consider the direction. So let's work out this angle in here. We know from trigonometry that tan theta is equal to opposite over adjacent. So that's 0.35 over 1.0. And so that tells us that theta is equal to 19 degrees. So this angle in here is 19 degrees. And so around this way, we've got that's 90 minus 19. So this angle in here is 71 degrees. And so the velocity of the babies is north 71 degrees east is the direction. Okay, but we've now got the velocities of the babies, but what we need is the velocities of the babies relative to the father. We've got them all relative to the bank, but the father's not moving, so this is just the velocities of the babies minus 0. And so we've just calculated that. That is 1.06. Now, because everything in the question is given to two significant figures, we should give our answer to two significant figures as well. So it's 1.1 meters per second, and it's north 71 degrees east. Okay, see what is the velocities of the babies relative to the mother? Okay, now in this case, we've got the velocities of the babies relative to the water and the velocity of the mother relative to the water. So we'll use their velocities relative to the water. So we need the velocities of the babies relative to the mother. So that is equal to 0.35 north meters per second minus, now the mother is not moving relative to the water. So that is equal to 0.35 meters per second north. Now, part D says, what is the velocity of the father relative to the babies? So this is just the opposite of what we did in B. So now we need the velocity of the father relative to the babies. And so that's 0 minus the velocities of the babies, where we've got the velocities of the babies here relative to the bank. And so that is just the opposite of this. So when we consider before it was going that way, now it's going, this is 19 degrees in there, and so this is the angle that we need, 71 degrees, and that's southwest. So this is equal to the same number, 1.1 meters per second, but it's now south, 71 degrees west. And then E, last part, it says if the babies make it all the way across the river, how far downstream from the father do they land? So what we need to do is work out how long it'll take them to get across the river, and then we know that downstream, every second they're in the water, they're being carried 1 meter downstream. So the time is equal to the distance over the speed. So they're going 21 meters, and they're going at 0.35 meters per second across the river. So that's the northwards velocity. And so that is equal to 60 seconds. And now each second that they're in the water, the river carries them 1 meter downstream. So the distance horizontally is equal to the time times the speed. So this is now 60 seconds times 1 meter per second. So this is equal to 60 meters. So they end up 60 meters downstream down here.